Hi, and welcome to my video on rational exponents. Recall, a rational number is a over b, where a and b belong to the integers, and b cannot be 0. So we'll have integers for a and b, and the denominator can't be 0. Examples: 1/2, -3/8, 4 or 4/1, -10/3, -3/1. So there's a rational number has no roots. That means, let's look at what we call a rational exponent. So that's exponent is the power of a number or an expression. So x to the 1/3, y to the 5, a to the -4/9, b to the -2. Remember, -2 is a -2/1, which is a rational number, but is also an integer. 5 is an integer, but -4/9 is a rational number, but is not an integer. 1/3 is not an integer. So let's look at the expression b to the p over q. So b to the p over q can be written as the q root of b to the p, or the q root of b, all bracket, to the p power. So we're going to write it either way. So let's write each of these down here as q to the b power p, or the q root of b all to the p power. So this is, the root is the 3, and that's x squared. Or we could have 3 to the x raised to the power of 2. So either or will do it. So notice the root is always the denominator. Root is 3, so we can write it either of these two ways. And number 2, that's the root is 5, so that's 2 to the 4. Or we can go the fifth root of 2 raised to the 4th power. So either or. And 1/2, a half, that's a 2, understood. Square root is a 2, so that's 3 to the 1. Or we could also write that the square root of 3. Another way is to write that as the cube root of 2 raised to the 1 power, and that works out to be the cube root of 2. See what I did then? I'm writing square root of 3. That's the square root. That's a 3 there. And that's the square root. The 2 is understood. So that's 3 square root to the 1. And that's square root of 3 also. So I just mixed it around. There's something that I do and I don't realize. Again, the base is 3. The root is the 2. This one is the 7th root of 5 squared. Or it's the 7th root of 5 all squared, either or. Now you could say this is the 7th root of 25 if you want to simplify it. You can make that the 5th root of 2 to the 4th 16. It's the same answer. Now let's reverse it. Write each as b to the p over q. So this is x is the base, and your root is 4, so that's on the bottom, and your power is 3. Your numerator is 3. This one is, the base is g, and the root is 5, and the power exponent, or the numerator of the exponent, is 2. And this one, that's understood to be a 2 there, so I'll just put it there so you can so that's a, and that's the square root, understood to be a 2, and 5 is the exponent, or the numerator of the exponent. We have h is the base, and the root is 3, and to the 7 on the top. And we have a base of x, 6 root, 6 is the denominator, 11 is the numerator. We have the d root, d. We have the root is 9, so that's your denominator, and 2 is your numerator. Again, the root is your denominator, and the extra power, it goes into numerator. Okay, let's use that to simplify these. Here we go. Simplify each. 9 to the 3. So there's two ways to do this. One way would be to say that's the square root of 9, like this. And the square root of 9 is 3, and 3 cubed is 3 times 3 times 3, which is 27. Another way to do it would be take the 9 and make it 3 squared and raise it to the 3 over 2. And because we have it 9 is 3 squared, this is the product of power. This is the multiplication of powers, so we can cancel. So we get 3 cubed, which is also 27. And the other way to do it would be to do the square root of 9 cubed, but that would make it longer. So the better way would be to do the square root of 9 to get the 3 and do cube, or take the 9 and raise it to 3 squared. If you did it this way, you'd have to take the 9 and cube it, but that's making it awkward. So if you did 9 as 3 squared cubed, that would be to the 6th, that would be 3 to the 6 over 2. That would be, so I wouldn't go this way because it makes 9 higher. I would go with one of these two. 8 to the negative 2/3. So another name for 8 is 2 cubed. And because you have 8 is 2 cubed, you got a power of a power, you multiply the 3's cancel. I get 2 to the negative 2, which is 1 over 2 squared, which is 1/4. Remember, also, the negative exponent can change to a positive exponent and make this a half. So you can go 2 to the negative 2 is 1 over 2 squared, which is 1/4. Or you can change your negative exponent to a positive, make the 2 over 1, make it a half, and then 1/2 squared is 1/4, either or. And right here we have a power of a power, so that's 36. And so we multiply these two, that's a positive a half. So we can write it either or. We can go, that's the square root of 36, because 1/2, 2 is the square root, 1 is the power, so that's a 6. Or you can go 36 is 6 squared to the 1/2, and they cancel to give us 6 to the 1, which is 6, your choice. And here we have a power of this product, so that's 8, or sorry, x 8 times 3/4 multiplied by x 4 times 3/4. So the 3/4 is multiplied in through. Or we can go, that's 4 and 8 goes 2, that's a 6. And 4 into 4 goes once, that's 3. So that when you multiply, you add. Another way to obey PEMDAS would be, what I always do, is can I simplify the inside of the bracket? Because of the same basis, I would make that x, and 8 plus 4 is 12. I would do that, and 4 into 12 goes 3, and that gives us a 9. Again, either or, but to simplify the inside first is the best way to go. Call it x to the 12, and then multiply your powers. And right here I have same basis, which is x, so that's 1/2, and we're going to add on a negative a half, and that's a 0, and x to the 0 is 1. When we multiply, we add the exponents. And we're multiplying here, so 4 times 5 makes 20, and we get x to the 7 over 3 times x to the, like that, so that's 20. Because of the same base as x, that's 7 over 3, add on negative 1/3, so that's a 20. And that's 7 subtract 1 is 6 over 3, so that's 20 to the x squared. We multiply the 4 and the 5 to get 20, and we multiply the exponentials. But when we multiply, remember, we add the exponents. And right here we have a power of a power in each of these. I have to do these powers first. 5's cancel. I get a to the 3. And these cancel. your power of a power, 2's cancel, you get a to the negative 1. And when we're dividing, we subtract the exponents. And dividing, so that's 3, subtract negative 1, double negative is positive, so that's a 4. Number 8, we have a monomial times a binomial. So let's write this down. We got x to the 3 over 2 times x to the half, add on x to the 3 over 2 times x to the negative a half. So the x to the 3 over 2 is multiplied by both of these expressions here. When we do, now I put it here first. Now I could have done this. I could have said, well, that's 3 over 2 times x to the half. You add, that's 4 over 2, which is x squared. I'm adding here, same basis as x, so add 3 over 2, add on a half is 2 over 2, which is 1. So x squared plus x. So again, x to the 3 over 2 is distributed in through these two, which I did here, and then I add exponents and simplify. Okay, let's continue. Again, the difference here is that I'm doing rational exponents, and they're done in a previous unit in Algebra 1 on exponents, but here they're a little bit more difficult. And we have a square here, so we have this binomial squared. So I'm going to write it down twice so you can see it, because I have the fractions. Then just to make sure, so when I square and multiply by itself, now I'm going to do 4. First is x to the half times x to the half. Then I'm going to multiply x to the half by x to the 7 over 2. Then I'm going to multiply x to the 7 over 2 times x to the half. And that's the same as this one right here. And we have x to the 7 over 2 times x to the 7 over 2. Notice I wrote it all down. First, outside, inside, last. There they are. And because we're multiplying, we add. A half and a half is 1. Because we're multiplying, we add. So that's 8 over 2, which is 4. And again, same term here, so we should get a 4. And we're multiplying here, 7 over 2, add on 7 over 2 is 14 over 2, which is 7. And to write that in that's an x to the 7. Descending order is x to the 7, x to the 4th, but there's 2 of them, so there's 2x to the 4th plus x. So again, I did the FOIL on this, and there they are, and I'm adding the exponents together, and then I'm putting in descending order. Number 10 is a little bit trickier, but the best way, because I have negative exponents, the smallest exponent is x to the negative 2 over 3. So what I'm going to do is multiply by top and bottom by x to the 2 over 3. So if I multiply top and bottom by x to the 2 over 3, notice x to the 2 over 3 divided by x to the 2 over 3 is 1. So I'm multiplying. So that's 4x to the 1/3 times x to the 2/3. Subtract 2x to the negative 2/3 times x to the 2/3. So I'm taking x to the 2/3 and multiplying by each of these monomials. And I'm doing the same on the bottom. So that's 4x to the 4 over 3 times x to the 2/3 minus x to the negative 2/3. So again, I took x to the 2/3 and multiplied by this monomial, and I took x to the 2/3 and multiplied by this one. And I'll go right here. When I multiply these, that gives me a 4, and that's x is a base, common. So I add, so I get 2 plus 1. 1 plus 2 is 3 over 3 is 1 minus 2. And when I multiply here, I add, so that gives me x to the 0. So x to the 0. I'll leave that for a second. Come back after. Multiply this one, and I get 4. And when I multiply, I add. So that's a 6 over 3, which is x squared minus, and they're the same bases of x. When I add, I get an x to the 0. So that becomes 4x minus 2. Notice the x to the 0. The 0 is with the x, not with the 2. So that's 2 times 1. All over, that's 4x squared. X to the 0 is 1. And we said simplify, so I can see a 2 common monomial. So 2 into 4 goes 4x divided by 2 is 2x. Negative 2 divided by 2 is 1. I factored the 2 out. And notice here I have the difference of two squares. I have 2x, 2x. I have a 1 and a 1. And the product is negative, so it's a plus and a minus. And right here, can I cancel? I have this binomial and this binomial, so that's 2 all over 2x plus 1. So you can see that this one is a little bit trickier. But a way to handle this one is to multiply by the opposite. The smallest exponent is x to the negative 2 over 3. So multiply all terms on top and bottom by the positive of that. So that's what gives you the zeros and helps you to simplify. Number 11, we want to factor. And when we factor, we look for the GCF. So we have an A that's common. So the smallest exponent of 5 over 2 and a half is a half. And in B, the smallest exponent of 5 over 2 and a half is a half. So if we notice a half, because I'm dividing, then 5 over 2, a to the 5 over 2 divided by a to the half. Because we're dividing, we subtract. So 5 over 2 subtract 1 over 2 is 4 over 2, which is 2. And they cancel out. So in other words, if I multiply back here, a to the half multiplied by a to the 2, 2 add on a half is 2 and a half, which is 5 over 2, and we get the b to the half that's there. Subtract. So when I divide now this expression here by this one, a to the half I don't need, so I need b's. So 5 over 2 subtract the half is 4 over 2, which is 2. And we got to assess factor. So again, what do we have? We have a squared minus b squared. So that's a, b, b. And notice the middle product is negative. There's a 0, a, b here, not in the middle. So that's a plus and a minus because it's the difference of two squares. So that's fully factored. So notice a to the half and b to the half is common to the two of these numbers. So I took it out and factored the difference of two squares. So that's a review of working with rational exponents. And again, if you like my video, click the like button. If you're not a subscriber, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. The content is on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video helped you. Bye-bye.